Hello everyone, welcome to Aircraft Structures Lab AE 314 and AE 727. My name is Neha Bhushan. I am a research scholar in Department of Aerospace Engineering, IIT Bombay. Today I am going to talk about strain measurement experiment. First let me explain you what is strain and why is it measured. Any material when subjected to loads undergoes deformation and this deformation is measured as strain. Strain is a change in length to the original length of the specimen. Strain is measured using foil or electrical resistance strain gauges, optical strain measurement sensors and digital image correlation. The strain measured from these devices will be used to compute the modulus of the material using Hooke's law. In the experiment, I will be showing you how to use foil gauges to measure strain in a material. Strain gauges are the metallic or semiconductor devices whose electrical resistance is sensitive to strain. They are usually bonded to the surface of the specimen by a bonding agent. When external loads act on the specimen, it undergoes deformation and correspondingly strain gauge undergoes deformation. This results in the change in resistance of the foil. The change in electrical resistance is measured in terms of change in output voltage of the Wheatstone bridge circuit, and that is related to the mechanical strain. Gauge factor of the strain gauge is the fractional change in resistance to the fractional change in length. In this experiment, we will be adding weights to the free end of the cantilever beam. There will be deformation corresponding to the load that is added. Top surface will be in tension and bottom surface will be in compression. In this experiment, we are using P3 strain indicator to measure strain from the strain gauges. P3 strain indicator can be used either in quarter bridge or half bridge or full bridge configurations for strain measurement. In the current experiment, we are using quarter bridge and half bridge. In the quarter bridge circuit, I am using top surface strain gauge and connecting it to the P3 strain indicator according to the bridge circuit configuration. One lead wire is connected to P plus and the other is connected to S minus, and as we are using 120 ohm resistance, to complete the circuit, we are using D120. We have 4 channels in the indicator. Strain gauge is connected to channel 1. So, we need to select channel 1 and activate it. Next, we need to select the bridge. So, since it is quarter bridge must be selected. And then we need to select the gauge factor, which is default 2.150, and the units of the strain which we see here is in microscale. So, then we need to balance the circuit initially. So, the initial strain is set to 0. Now, I am adding 50 gram weight to the weighing pan and strain corresponding to it will be shown in the indicator. I am adding 100 grams and now the total load is 150 grams and strain corresponding to it is shown in the indicator. Now, I have connected the tension and compression side strain gauges in the half bridge configuration. In the bridge configuration, I am changing it to half bridge and balance the circuit initially. For a 50 gram load, the strain in the aluminum in the half bridge configuration is shown on the indicator. For 150 grams, the strain corresponding to it is shown. I will be providing you the load and corresponding strain data. Stress can be computed using elementary beam theory. So, bending stress can be computed using the formula mentioned here. Plot stress versus strain and find the modulus using the slope. So, you need to solve this assignment and submit your report.